Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history. Beyond our dreams and our sights, life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
Well, hello there. Welcome to Mr. Rogers' Neighborhood. Hi, guys. Welcome. My voice is a little bit rough, but that's because I talk a lot. I do have a bottle of water just in case. This thing you see here, that's the moon, but you all knew that. So I want to welcome all of you here tonight. Daryl has a night off. He says he's a little under the weather, so that's what it is, you know. And our streaming service has collapsed twice so far, but we're hoping it's going to stay up. But on the other hand, we do have two systems running. So I've got the other observatory running here, and not that. But when you look at the moon in this one, this is the view of the Benson Plateau telescope, all right, live. And this one is the view from the Sonoran Desert one, and you can see the difference in the size of the fields. These are the fields that are actually set. I'll just go to auto on both so you can see. So that's the actual size of the field. Okay, so it's 3 full moons across and 2 full moons tall. All right, and that's like 1.5 degrees by 1 degree. And then we have this other guy, all right, this one here, and this one is a system that is actually, I'll do the same, the auto is already set, and you can see it's just slightly smaller than the full moon. Actually, it's about the size of a full moon, so it's about half a degree, right, in size. So that's what we're looking at. For those who have just joined us and haven't seen this before, this is the telescope in the building out there in Benson, Arizona. This is a visual representation of the telescope. I can move all around it and make sure its positioning is correct. All right, and then we have a let's do it this way. Okay, and that's south, and south is behind us in this view, so we're good. And then we have the control system, which is right here. Okay, that's one. I have another control system over here, which I'm going to be using more likely tonight. We're going to be going to a few different spots tonight just to check things out. I just wanted to say hi to the folks that are here now. And Donald Kunzer says, I have two computers and one says the stream hasn't started yet. Yeah, that does happen sometimes. I've seen that. And I will be checking out something right now. Just a
Deep Sky Clock event.
Yes, I have a alert going as well, so we're good there. And now let me do one more bit of housekeeping while we're waiting. You can look at the moon here. This is a beautiful image of the moon. It's rock steady night out there. It really looks nice. I'm very, very happy with this. And so we should be able to get some good shots. Now, obviously we have some issues, and that is that the moon is out and we have to avoid the moon, right? So we'll look at the moon a little bit, and then with our filters we can actually get some nice shots of the rest of the sky and the stars, and maybe some nebulae or a couple galaxies. We're going to try it and see what we get. All right, I'm going to just do another final little tweak here. I just did it. It's done, and I'm saving it. And I believe we're good now. So here we are. Okay, all back together. All right, just want to say hi to everybody. Michael Hedrick was the first one here. Well done, nicely done. Carl Becker is with us. Kate Lawler, hi Kate, nice to see you. Fred Phonebone is with us. You noticed the date was wrong earlier. That's because it took a little bit for the date and time algorithm to kick in, but it did, so we're good. Sally Forth is with us. Tim F is with us, and it's good to see you guys here. And you're the early crowd. Donald Kunzer, nice to see you. Toner's with us. Hey, Toner Low. Sam S is with us. Good to see you as well. And Kurt, how you doing, man? Mark, the mad scientist. Am I the mad scientist, or are you? Are you, Kurt? Are you the mad scientist? And Daisy and Zoe Amethyst, nice to see you guys. A crazy sort of day. I know the feeling. And then we have Steven, Mr. Django. Nice to see you, Steven. How are things in Belgium this morning? Good to see you joining us tonight. Karen Belmont's here, Blues Traveler. And you know what? We'll have more people joining as the night wears on. And so we're gonna do our best to try and keep our streaming service from collapsing. I don't know why it collapsed before, but it did twice. So if all of a sudden the stream goes away, not my fault. Okay, it's outside my purview. So this is the one machine. This is the other, I should say machine, telescope. This is the other telescope. Okay, so this is the one out in the Sonoran Desert, and we can go check out. See, we're at the moon right here. All right, but there's some things we can go check out while we're here, and I would like to do that. Actually, let me go here. Let's see if we can do this. This is an interesting nebula, and this might be a little low, but we're going to try it anyway, see if it works. Okay, so we're going to leave the moon behind here in just a sec, and we're going to head to this other location. Okay, the telescope is already moving. You can see it right there moving. Okay, and we're locked on. Let's go to our higher gain, 250. Let's go to our 1 second low light mode. And let's actually do this. Okay. Oh yeah, there's our stars. Now, the thing we're looking for is probably right here. But I'm going to take a shot of this. Now, it's a little bright sky, right? Because we're also not quite fully dark out there yet. But I want to try and take a shot of this particular location. Well, first of all, let me see if I can give us an identifier. Now, as you can see, there's lots of stuff going on here. Okay, and dead center is what we're looking at, 2170, NGC 2170. It's a reflection nebula, all right? So we're going to give that a shot. Okay, and so to do that, we're going to set up an exposure here. We're going to say, we'll say 25 seconds. Again, this is our wide field system. And we're going to go in at a gain of 250. So off we go. And we'll come out of our low light mode and go into our deep sky mode. All right. And we'll check out what we see. You can see the progress bar. Well, not yet, you can't, but you will in just a second. Okay, here comes the progress bar. Actually, not quite there. Yeah, I'll get that to show. All right, so we have our first image coming in here in just a moment. Let's make sure that we got it. There it is. As you can see, the colors are a little messed up. Let's color correct that. And let's look at our... All right, here we go. And now let's get rid of that. Let's set this up. Okay. All right, so now we have to go into our enhancement here. We're going to put on our color correction. Watch this, color noise reduction. All right, and then boom, instantly looks better. And we'll let that drive up. Now you notice the red around the fringes. That's the sunset light that infects our views before it's fully dark out there. So we'll just wait it out, check it out. But look at this beautiful red nebula forming over here. Beautiful blue one here. This is called the Angel Nebula. Carl Becker asks if we'll be watching T Corona Bohr Nova with our scopes. Yeah, actually, I'm glad you mentioned that. When Corona Borealis actually comes up to where we can see it, we will actually look at it. Yes, and we'll be looking at it with the other system as well, the system over here. Okay, which is still currently looking at the moon, so we'll check that out as well. All right, and let's see now. Okay, so we'll let that come in. I'm just gonna we're guiding obviously here, so I'm gonna clear that for a moment and see if the next one that comes in will come in without as much red. Yeah, see, we're a little bit early. We got to make sure that the sky is completely dark. To your eye, it would look dark out there right now, but as you can see, we see the red from the sunset light. You may recall, if you watched any of my other streams, see, it's getting a little better now. When we looked at the other streams, I showed you some photos that I took of the night sky. The night sky that was showing the full Milky Way, the summer Milky Way. And when I took the time exposure showing the full Milky Way, you saw the red sunset in the same shot. Really kind of odd. You wouldn't expect to see the sunset in such a shot, but you can. You know, as William Shatner would say, I think you could see it because it's there. Scotty, get us out of here. All right, so here we go. You can see now this beautiful nebula is starting to form. You see some more color in here. I want to take us over to the other telescope while this is building over here. Okay, that's the nebula I was just talking about. And over here now, looking at the moon, what I'm going to do now is I'm going to bring us to the same thing from this telescope. All right, and I have it set up, all ready to go. And we're going to go there and see how it looks. So you'll see the telescope up here move. It's going to angle over toward the west. West is toward that side out there. And here comes the telescope now. As it comes in, it's going to slide right in. And let's come over here and maximize this. And we're going to go to our low light mode. All right. And I'm going to adjust our image controls here. That happens on occasion. There we go. All right. So here's our image, and now what I want to do is see if it recognizes anything here now, because it's a totally different machine, totally different system, and there it is. So we have the reflection nebula dead center in this telescope now. So now let's do another 25-second photo, but what we're going to do first is go into our guiding system, which is up, and I'm going to make sure that we actually can capture a star in here. Let's see if we'll grab one. Not effectively. So what I'll do is I'm going to go to 1.5 seconds with exposure. Do another exposure. Okay, now we see more stars in here. And let's see if we can grab any of these. Aha. That's good. Let's let that settle in. There we go. And we're going to guide on that now. And now we can do our 25-second exposure and see if this works. So now we come out of this, go into our deep sky mode. Okay, this is the Angel Nebula. All right, and so the Angel Nebula, as I mentioned earlier, that we're looking at here, this one here, again, the red of the sky is much more pronounced here. And you can, we have a satellite that went through. Let's color correct this. There we go. Okay, we have a center glow here that's partly from the moon. Okay, and let's come back here. Let's come back here, color correct this. Yeah. And we're going to make sure that this is focused. And we're going to color correct now. Yeah, we got a little problem there. I'm going to unstack this last one. There we go. And now we'll just do this. So you can see how the nebula is starting to form in here. And what I'll do is I'm gonna move this down a little bit. Yeah, this is. I have to get. There we go. I got to get this guiding system to work again. So we're gonna say stop for now, and we're gonna get us a new set of stars. All right. And we'll try that. Let's come back down here. I need to get the stars. Or I can do... Let me stop here. Just for a minute. So you should be able to guide. Okay, now let's see. Whoop, hang on. Let's see what we got here. I think I might have turned something down too much. No, I didn't. There we go. 1, 2, testing. Yeah, here I am. Okay, that was what I wanted to do. Sorry about that. I had it turned down. Okay, so you can see we're getting some nebulae coming in here. This is the Angel Nebula. Again, it's a close-up. And I want to try to get something out of this that's a little bit more valuable. So, let's come back here. I don't know why it's doing that. It's guiding right there. Hi, Izabela. Hey, KP, how you doing? Nice to see you. Is that Kathy with a different ID? Not sure. Not sure. Let's go see the other exposure, see how that's doing. Okay. Let's do a zoom view and give us a little more latitude on this. Oops, sorry about that. You don't want to see my program. We'll back this out. Okay. Color correct. Oh yeah, there we go. Really pretty. You can start to see some of the blues and reds coming in here. Again, this is the wide angle, wide field. All right. Okay. Let's back over here. Okay, we're going to start that over again because this field is not satisfactory. Let me go do this again. All right. Oh, wow. KP, that you Kathy? That's Kathy, right? Oh my gosh, thank you, Kathy. Alright, I'm gonna do this here. Actually, let's go back to this. Okay. Alright, so we're guiding on that. That should be good. All right, Kathy, thank you so much. That's you're such a sweetheart. Thank you so much. Oh man, if you only knew, if you only knew what it is involved to do both this building and this building, it's great. Hey, Alicia, nice to see you. Oh, thank you, Kathy. Thank you so much. Wow. One day we're gonna meet in person. I'll be at Contact in the Desert. May 31st through June 2nd. I'll be in Colorado twice. I'll be in Colorado May 16th through 18th teaching photo and video analysis class out there. Then I'm back on August 25th for a few days for a conference out there that's called Snippy the Horse. It's at snippy.space. I'm also at Pine Bush this year, which will be June 7th. So a week after Contact, I got to go there. And that's the one so far. Then up in September, I'll be in Nova Scotia speaking at the Shag Harbor Conference, which is really cool. Ronald is here. Hi, Ronald. Ronald's watching on his phone. Let's send our love to Ronald because he's in the hospital tonight, but he's under control. He'll be okay. But let's send our love to him. He's a wonderful guy, and he's actually needs a little bit of thoughtful thought and good vibes tonight. right. I should have known better than to try the Angel Nebula with this, because this is actually not as good as I was hoping. Yeah, you can see some detail, but the moonlight is actually causing it to break toward the red. Unfortunately, that happens occasionally. Donald, hey, thank you. Whoa, hey, Donald Kunzer's birthday, guys. He's going to be 64. Well, I beat you to it. I'm already 64. Very nice, Donald. Thank you. All right. And Tricia Ferreira. Hey, thank you. Oh, my gosh. Hey, Tricia, that's so cool. Thank you so much. You guys are so incredible. Hey, Creamers. Creamers? Hey. Oh my gosh, Creamers is here. Creamers, did you realize? I think you won a pair of binoculars and you never came back to claim them. Please send me an email. Look at here. See, look, Creamers. Look at the screen right there. ContactSkyTour@gmail.com. Send me your email, okay, or send me your address or whatever, because I think in the contest you won, and then you're never seen again until tonight. Yes, Creamers, really. So get your button gear and send me your address and stuff. Again, ContactSkyTour@gmail.com, right there on the screen. Okay? I've been looking for you. I tried to find your page or your YouTube channel. It's just not there. And I couldn't find a way to connect with you. I am so glad that you joined tonight. Thank you. And Kathy and Donald and Tricia, thank you so much for these donations. That's fantastic. Yeah, you're gonna have just and Creamers. You got some beautiful binoculars tonight. You won, like, gosh, it had to be several months ago. You know, I'll make sure that they're still out there for you. I mean, they should be. I don't see why not. That's why it's so important to stick around for the final announcement, so you know whether you won or not. It's really important, man. Kathy, I should have a birthday more often. Yeah. Yeah, Carl Becker, that's very nice. To Ronald, thank you. Yeah, see, Toner Low, he says, I remember that giveaway. Remember that, Toner? We said Creamers won. Where is Creamers? I put out a message. Come on, give me your message. Again, don't skip it this time, Creamers. Okay, ContactSkyTour@gmail.com. I feel like a weatherman. And tonight's low is tracking right here. ContactSkyTour@gmail.com. Get me your address and stuff so we can actually make sure we still have a pair of binoculars to send you, because you want them. Man, okay. All right, so that said, I wanted to also say that this object is not impressing me tonight. It normally does, but I think yeah, I think it's the other way around. I think we have to probably ditch this, unfortunately. I would love to get a picture of it that's nice. Maybe there might be more detail hidden in here. Let's actually over process it for a moment just to see what's in there. Yeah, see, those colors are those are actually induced colors. The moon is interfering, Donald, yes. So, but there are some things we can look at that are actually good. So, I'm gonna get out of this because this is unfortunately not living up to what I was hoping. But when the moon is not out, this looks very beautiful. Okay. All right, so this is we're out at the streaming telescope in the Sonoran Desert here. And, yes, happy birthday, Kathy. You know, and don't forget Donald. Donald's got a 64th birthday coming up, right, Donald? Isn't that what you just said? Isn't that what I saw? Yeah, in less than an hour you'll be 64. Well, happy birthday to you and to Kathy. I wish I had birthday music to play. I would, because you know that's me. I'll do that. Yeah. No, I'm not singing it. Well, I could. You want it in Spanish? Feliz cumpleaños a tu. Feliz cumpleaños a tu. And all right, let's see. See, we got a spider web out there in the Sonoran building. Okay, let's go back here because I would like to. You see, we're also near the horizon, so it's really bad viewing out there when you're near the horizon so much. So what we're going to try and do, actually, I'm going to try this. Let's see. Let's go over to the Leo Triplet, because this is a really pretty view. Let's go to the Leo Triplet here, and you'll watch the telescope swing right around. Okay, it's going to head to the east, which is going that way. All right. So let's go take a look and see if we get the Leo Triplet in here. Hey, Tiffany, how are you? Hey, Tiffany, I wanted to mention that a previous winner that never got his, he never came back, actually, is Creamers. And Creamers is here, and he had won a pair of binoculars. Do you happen to have a pair there that we could use, or no? If not, I understand. Okay, let's see where we are here. Egads, that's quite a few galaxies. Wow. Look at that. Look at all these things. See how many galaxies are here in this one view? Look at that. Okay, that's fantastic. Oh, there goes a Starlink satellite. We're at a 1 second exposure, so we get like a 1 second. Okay, that's IC 2734. And let's see. Let's actually put the Leo Triplet. It's up there. Let's center it into view. Yes, center it into view. So this is going to come down. Here it comes, and there's the galaxies. There's those two, M65, M66, and if we go up just a little bit, okay, then we'll be able to see the Hamburger Galaxy, which is above it. Here it is. It's coming in now. It's NGC 26 or 3628 right there. Now here's the thing that's interesting, guys. Every one of these indications is an indication for a galaxy. And these galaxies may have anywhere from 100 billion to more, to 400 billion stars, maybe more. The Andromeda Galaxy, for instance, has literally 1 trillion stars at last estimate. And the Andromeda Galaxy is huge. And it's much, much more massive than our Milky Way galaxy. So when you look at all these galaxies here, you say, wow, how many other potential life forms might be looking back at us? And the answer is potentially quite a lot. You know, we don't know for sure, but it's very possible that there's a lot of life forms looking back at us from these galaxies. All right, so we are interested in this view in this faint galaxy here, and then these two galaxies here. And what we're going to do is we're going to take an image of them. I'm going to just bring this down just a little bit more. Just to get this a little bit more into the field. That's good. All right, so now we have it here, here, and here. This is the Leo Triplet right here, these three. Very cool. Okay, so we are going to pop out of this and go into our guiding mode here, and let's see. All right, we're guiding already, so let's actually come in and do a 25-second shot of this and see what we get. Okay, and so while that's coming in, we're going to do this, bring up our deep sky mode, and go into our, yeah, I'm going to get rid of that. That's the previous one. So we'll drop out of that, and now our wide field shot should encompass the Hamburger Galaxy and 65 and 66. And there they are. Okay. So what we'll do is we're going to move this down a little bit. Okay. And we're going to color correct. There we go. And we're going to take out some of the red because that's not supposed to be there. It's a little better. Oh, wow, Kathy. Kathy says her mom missed her 101st birthday by 8 days. Oh, wow. Okay. Now, if we go into the other telescope right now, what I want to do is I want to take us here, and we're going to leave this behind because it didn't really work too well. It's very low to the horizon, as you can tell by the telescope angling down. It's why we don't look close to the horizon, guys. We don't get any value from looking so close to the horizon, unfortunately, because we're looking through so much air mass, so much air, that it's pretty bad. All right, here's what we're going to do. We're going to go back now to here, and now we're going to find the Leo Triplet, which if we zoom out a little bit, you'll see it. It's up by the moon. So the moon does interfere with things. But if we zoom in here, you'll see the Leo Triplet right there. Okay. And what we need to do is look only for one of these. If we look at the field of view, okay, our other field of view is this big. And this one is that big. That's our field of view. So, wow, you know, we got to try and focus on one thing versus any other. And we're going to do, we'll go to measure 96. Let's see if we can do this guy right here. All right. So the telescope now is going to swing around and go the other way. And if you want to know what it's doing, you just watch the screen here and you'll see what it's doing. Okay, we look at the telescope. It's swinging its back end around like this. You can see it doing it there. And it's going to look toward the east, which is out over this. This is the roof segment that's not fully off the building yet. We're going to fix that. And we're going to find that we'll have, hopefully we'll have our galaxy in here. And this looks like it right here. And I'm on a 25-second, oops, maybe not. It looks like it's doing a... Okay, we'll get it. I forgot to go back to the 1 second shot here. I was wondering why it looked that way. It looked weird. Okay. Okay, so now we're locked on something. Let's find out if it knows exactly where that is. Couldn't find it. All right. All right, so what we're going to do is we're going to move the telescope a little bit. Okay, let's see if it knows this field. Because if it knows this field, then we'll be able to find the other Oh, goody. There we go. All right. So let's take, let's try this. I already selected, I believe, M96. Yeah. So if I sit here and I say, solve and resync, it's going to solve for the field and then move that galaxy we selected right into the center of the view. Let's move this out of the way. All right. Okay, now. No, we're way down there. Oh. I was at the wrong place. Oh, I'm sorry, guys. I hit the wrong one. Okay. So this is what I want. And now I'm going to say solve and resync, and then we'll go right to that galaxy. It had the galaxy in here like I asked. I had the wrong galaxy selected. Okay. Make sure I did that right. Let's do this. Well, there we go. That's more like it. Okay, so there's M66. That's right in the middle. Okay, and M66 is a beautiful galaxy. And as far as a type of galaxy, we'll notice that when we look at its type, it says it's an SAB. That means it's a barred spiral, so it has a large extended nucleus in its center. And this telescope is very effective on galaxies, where we can use what's called focal length magnification, basically. All right, so let's go here and make sure we can get some stars. I'm going to stop on this here. Let's do a 1.5 second exposure. Don't see many stars, but we don't need many. All right, let's see if we can grab stars. That's a very faint star. Let's try. This song sounds like Terminator. Well, that's where it ends. All right, let's do 2 seconds. Okay, stars are a little more pronounced now. And okay. Let's select one. Maybe this one. That's a double star, it looks like. All right. Almost sounds like Cylons in the background. Yeah, it does. All right, let's try something here. Let's do a 25-second photo here of this. Okay, and let's get out of our low light mode, and we'll go into our live stack here. Active stacking. Meanwhile, let's check out what the other telescope is doing. Yeah. Oh yeah, look at this. This is the galaxy we're looking at in the other telescope. Only this galaxy is showing up in there. And there's the hamburger galaxy. Why is it called that? It looks like a hamburger. I think whoever was looking at this galaxy must have been hungry. Let's color correct, see if we can darken this up. A little bit. And we always get a little bit of a redder sky. So I've got to knock out some of the red. This is more appropriate now. Okay, so there is the triplet. And we've got this labeled. So I will save it. There we go, Leo Triplet, and save exactly as seen. Okay, and now let's go to the other telescope. And we're gonna color correct this because the color is way off on this one too. Well, I guess it is. I've had this happen before and I don't know why it does this. Look at the detail though in those spiral arms, huh? Why does it do that? That's not what I want. I'll be investigating why it does that. Let's go back here. Let me do this. Yeah, okay. It'd be great if that red was the real color, but it's not. And what we can do is do like we did in the 1800s. We could just take a black and white image like this. Now it's a monochrome image and we can see the detail that we want to see. Look at that. See that arm of the galaxy there is really impressive. And we've got 6 shots taken here. You can see the details starting to flesh out. That's really cool. And we're unable to color correct it properly, probably because of the moonlight. But that's alright. We can do it like this. Hey, Heinz Ferry's with us. Yeah, Creamer says classic spiral arms, but look at this line here. See that line? This is an extension of the nucleus of this galaxy. And at the end of this one, you see this arm coming off. At the end of this one, okay, you see this arm coming off. It goes all the way around. And then there's outer arms that come off of those too. This is the barred spiral. It's a bar in here. Hey, Marianne. Marianne Robb is with us. You know. Incredible. Marianne, Donald Kunzer, and Tricia and Kathy. It's Kathy's birthday, and Donald Kunzer is going to be 64 in a little while, just a few minutes. But all 3 of them gave us a donation tonight. It was really nice of them. Okay, now I'm at a gain of 250 right here. So just again, just by a means of pointing a few things out, that's the view of the telescope in the building. This is a hypothetical view that I can move around. Here's one of the telescope control segments, but I don't use it as often. Here is our stacking and processing window. Here's our main window. And the most important thing is the exposure control here, how long we're exposing the sensor, and how sensitive we're making the sensor right here, the gain. Okay, so these values are the most important. This obviously moves the telescope down here, so we have a telescope movement segment down here, and then below we have a focus. The system works very well, and we get a lot of good mileage out of this. Now I'm going to try and extract a little more data here. Yeah, look at that. Wow. And the guiding is doing well. We've only lost 1 out of 11, out of 12, I mean. So we look at our half width maximum. You can see the filter was rejected this one here because it was a little too high. That's fine. I reject bad images for the stack. Really nice. Oh man. I prefer the color images, Karen. She asked, like, what do we like the color versus the black and white? But when the moon is out, sometimes our color is fooled, and so we end up looking like this. And if I go to color correct, it ends up with the red being really buried up there, and it's not right. So that's a problem. So what I'll do is, in situations like that, I'll just drop it down. Okay, and then we can do a color correction, but it's just looking at the relative contributions of the R, G, and the B. Izabela says, there's nothing better than coffee and STLS early morning at 5 a.m. Egats. Hey, Kevin, thanks for coming out. And he says, another great show. Thanks. Yeah, not bad. We're doing good. Let me take us over to the other telescope here just so we can see how we're doing. Here is the Sonoran scope, and we're looking at our Leo Triplet. Here you see the field of view of this telescope is huge. So we have all three of the Leo Triplet galaxies in here. But if I zoom in on this guy, okay, you see how it's not really as clear? And if we come back to this other one, look how much clearer it is. Okay, this is really clear, and we're only at 50% of the sensor. Okay, we can actually do a lot better. Now what I'm going to do, however, is I'm going to drag this mid-range one down to get rid of some of the noise. Look at that. Look at all the knots and convolutions in here. Isn't that incredible? That's amazing. Wow. I really like that. And you can see the bar very brightly here. And it's off the end of those bars where these spiral arms from. So we got this bar here, and the spiral arm goes out and around and down like this. This spiral arm comes out, and the spiral arm goes around and down and around like this. So that's what they do. They wind around like this. Tricia Ferrer says, mind-boggling. It is, isn't it, though? Elizabeth Monteith, how are you? Actually, she says, have you ever considered investigating underwater? Yes, as a matter of fact, I have. I was working on an underwater sensor array, actually, to detect underwater objects that might be traveling underwater, like USOs, unknown submerged objects. Now, I'm an astronomer, right? That's what I do professionally, as you can see. But inner space and outer space are kind of similar, aren't they? You can die in both, okay? But you reverse the sign on the pressure equation when you go down in the water versus when you go out in space. So in space, your hull has to contain the pressure. Underwater, it has to keep out the pressure. So it's the other way, as you can obviously know. So the question becomes, when you look at the underwater area, underwater arena, for say looking for say extraterrestrial life, right? Well, again, as an astronomer, I know for a fact that it's not impossible to travel between the stars anymore. The guy I know, Avi Loeb at Harvard, I've worked with him, as I mentioned to you before, a few times on different programs and things. And Avi thinks they travel interdimensionally, and so do I. I've been saying that for about 4.5 years now. Okay, he just came out and said it about 6 to 8 months ago. Now, what's that mean, interdimensional? Well, it means traveling in a way that you're not subject to the laws in our 4 dimensions, which is X, Y, and Z moving through time. And so imagine a mode of travel where you can pop out of these 4 dimensions and go into a 5th one out here. Okay, this 5th one, if you look at me down here, this 5th one over here is a dimension where the universe, the farther in you go, the universe gets smaller around you. And as you leave, well, when you're in there, if you travel an amount of distance in there, when you pop out, that distance you traveled inside that 5th dimension is expanded to this massive amount outside. Why? It looks like this. You're inside and you travel 12 inches. When you come out, that 12 inches might have, depending on how far in you go, to this fifth dimension. The farther in you go, the smaller the universe becomes. So conceivably, you could travel into this fifth dimension so far that when you come out, that 1 foot, that 12 inches you traveled inside that fifth dimension could translate to, say, from here to the moon. Okay? And that's a concept that's very hard for us to understand because there's a lot of things that would happen. Just looking beautiful. There's a lot of things that would happen when you actually travel that kind of distance. And how does that look? If you're in a ship, as soon as you popped into this fifth dimension, your ship would literally disappear. It'd be gone right before your eyes. True invisible. Boom, gone for real. Okay? And then it pops back in at another location. It doesn't travel from point A to point B and through all the intervening space in between. No. It travels from this X, Y, and Z coordinate here into this fifth dimension and appears at this X, Y, and Z coordinate here. Does not travel in between. So, depending on how far into the fifth dimension you can go, where you compress the universe around you, when you come back out, you can just appear at a new location. And so, to our eyes, to our sensors, to anything looking here on Earth, that object will be moving what looks like unbelievable speed. You'd see 90-degree turns. You'd say, nothing could survive that. And you're right. Nothing can. Not even them, if they exist, right? As I think they may. What's happening is they don't have engines. All they do is pop out and pop back in. It's a pop in, pop out formula. So they could go to this point and then go to this point and then to this point and then go to that point. But to our sensors, it looks like they're going voop, like a 90-degree turn. Whoa, nothing can survive that. Well, they do. Because they're just, to them, the scenery's just changing and they don't even feel any forces. How about that? So, it's completely different from what you think, what you may think. So, that said, I hope that makes some sense to you. It makes sense to me. But then again, I'm a little crazy, right? So, here's our full field with this galaxy. Look at the beautiful galaxy. I'm going to actually I'm going to enhance it now. Watch this. Watch the detail show up. Look at that. Now we zoom back in again. You see more detail. Look at this. Look at the dark lanes and these spiral arms. Isn't that incredible? Oh, yeah. Now, this is it's called an unsharp mask. I usually don't go that high, so I'm going to drop it back down just a little bit. Because you can go really high. I mean, if you go really high, okay, then it looks like it's pretty good, but it actually does look pretty good. I'll leave that. I'm going to actually save that. Okay. All right. Before I do that, though, I am going to take that galaxy and set the target name. Okay. Now I'll save it. And save it exactly as seen. That's something. I'll try the color again just to see if anything has changed. Moonlight does a number on us. Okay, I'll try to adjust a little bit. Okay, now what's really going on is the center of this galaxy should be yellowish, and this green. You look at the curves; they're not aligned with each other. The red curve should be underneath the red, the green and the blue. Okay, and when you do that, that color should be matched, but it's not, and that's part of the problem with the moonlight. So tonight, what we're doing is we're just using, on this one right now for this particular photo, we're just going to do black and white because you can see it better. Look at that. Now let's zoom in more. This is at 44%. Here's 89%. You can see some noise, right? But we can combat that. We can there's actually more filters I can use too. But let's try this. Drop this down a little. Okay. And then come over here And this is about as dark as we can get it. I don't go past the peak on this, because then we'll lose data. So if you come out here, you'll see subtle data out here, right? If we go too far, that subtle data gets destroyed. See? So this is actually pretty good for this photo. And the guiding is really perfect. We got thorough 36 shots here. That's nice. Yep. Very nice. Blues Traveler says that giant shadow. Oh, that giant shadow 8 to the left. Yeah, okay. This little 8 number you see there, if we actually show you, if I show you that, that's actually an artifact on the sensor. Okay. And we're gonna actually replace this camera with another one. This camera has been through the mill, no pun intended, and so we're gonna replace it with a better camera. We already have one in mind. Wow, this is nice. Really nice, huh, guys? This is really pretty. All right, so that's measure 66 here. All right, and what you get on the actual picture when you go to SkyTour or SkyTourLive.org, this is the actual photo you get right here. All right, so you can download that and enjoy it. Okay, so we got that. Now, if we go back to our other view, check it out. Check this out. Look at this view. Okay, this is the same galaxy. This is the galaxy we were just photographing right here. Okay, so here's what it looks like when you can see it in detail, and here's what it looks like when you don't have as much detail. Now, this is a wide field scope, so we don't get the detail that we might ordinarily get, and that's part of the problem. Notice it's tinted toward the red. That's actually again thanks to the moon. All right. So that said, let's do this. Let's pull this down. Yeah, you see we got green encroaching. We don't want that. That's kind of okay. So if I zoom out, all right, you'll see all of it. This is the full field size here. All right. Really neat. We'll save this exactly as it is. And keep in mind the images tonight are not as good with the moon out. Okay, if we should be looking at the moon and only the moon tonight, because the moon's in exactly the wrong place to do faint things. But I figured, you know, you guys want to enjoy it, want to be here. I've got the two buildings running here. And it's just looking really pretty, so why not? And so that's good. That's quite a lot. That's 62 images here. So I'm going to save that one more time. Save exactly as seen. All right. Okay, and then I'm going to come out of here because that's more than enough. And then we'll go into our low light mode and hang out in low light mode for a bit before we go to our next object. Okay, so there's low light mode. You can see the Hamburger Galaxy faintly, and you can see 66 and 65 here. And if we come back here and center on these, you can see that we've been photographing this exact location. Okay, we've got this one and this one in here. Sorry, let me just get back here to show you. Sorry. Okay, so we've been photographing this section right here, this, and then the Hamburger Galaxy. And that's exactly what we see here. This galaxy and this galaxy, and then the Hamburger Galaxy. This one's fainter than these other two. All right, so that said, let's go back to our other telescope. And let's stop doing that. And let's do one more save here. That's really looking nice. Okay. And save exactly a scene. Now let's check this out. Let's go here. And let's go back to this. And why don't we do this? Why don't we move over to this triplet family member and do this one? All right, first things first, we're going to stop doing this guiding over here. All right, we're going to come out of this. We're going to get out of here because we've saved it. We're going to go to the low light mode. And you'll notice that we're doing the same thing across the two different telescope systems. Okay, so there's the galaxy that we're just in. All right, and we're going to zoom out now a little bit because we can. Okay. Here we go. Just bring it right back in here. So that's the zoomed out window. Now what we'll do is head over to this other component, this other entry, which is really cool. So we'll do that now. And it should slide right over. And we should see it. Let's see where we are. It's interesting. And now if we do the identification, now it's M65 that we're at, right? And get it correct. All right, we're at M65 now. Yes, okay, that's right. Not enough stars. All right, let's do a quick exposure to make sure that that's exactly what we've got. And we will come out of the low light mode and we'll get rid of this guy and go to live stack mode. It may or may not look good because we may not have a guiding solution for this. All right, well, we do at the moment. I'm going to imagine that our colors are still going to be messed up. Yeah. Okay, so we'll be in black and white mode for this one. Let me just zoom us out just a bit. Okay, so this is measure 65 now. And let's do this. 65, set the target name. Okay. So now we are in measure 65. And so we're going to capture this. We've got 2 frames here so far. We're going to capture a few more, obviously. And over in this side, in this view, we're looking at this guy right now. Okay. So while the other one is building, what I want to do is find another object that I'd like to take you to. And we'll do that. All right, good. It's not that late yet. Good. All right. Now, see where the moon is? It's exactly in the wrong place. Unfortunately. But let's come down here. And let's see. We'll find one more thing here that I think is good. Yeah, and its elevation is about 35 degrees above the horizon. That might be good enough. So let's give that a try, shall we? All right, so we're going to go to that with this telescope. And we'll let it do its thing. It's going to be looking toward the west. Okay, southwest. All right, and there it is right there. And we're gonna move it back into the center. Actually, I don't need to. I can just have this do it. Tell it nearby. Okay, and we're gonna take Thor's helmet and we're gonna center it into view. Yes, center it into view. Okay. There we go. All right. Meanwhile, while that's centering up, that's good now. I'm going to zoom in here and see how our focus is doing. It's looking a little soft. Yeah, it is. I'm going to refocus right now. Let that one do a refocus run. And while it's doing a focus run, we will go back to the other one and work on that. So we're going to focus this now. Okay, that was a little too much. I'm going to drag that back. Okay. Okay. Now we'll do a reset and a focus run. Okay, while we're focusing, we're going to run over here to the other telescope and see what it looks like. Ooh, look at this. Wow. Look at that beautiful dark lane in there. This is stunning. Let me see if we can get a little more detail in here. Oh, look at that, guys. Wow. Yes, there's no substitute for what we call focal length, is there? There's the nucleus of this galaxy. Now in here, this galaxy has so much going on. These dark lanes in here are areas where stars that have gone supernova and ejected their contents to space, molecules have been made in space that ended up linking together and bonding. And this is something that is absolutely incredible. And this is what we see, you know, when we see these things happening. Okay. Now, I am guiding on this one little star right here, and I'm going to let it go because it's working. All right. Kathy Pernisek's got 3 more minutes before she is at her birthday. I'm really impressed with that, Kathy. I'm impressed with that. Yeah. As she said, 3 more minutes, but how long ago was that, Kathy? Oh, no. Ay, ay, ay. Okay. Hey, Carl, thank you for coming. Thank you so much, and we will see you a little bit later. Next stream. Let's see here. Do this. Okay. This is really something. I'm really liking this. Really, really pretty. Wow. Yeah, there's something to be said for black and white imagery. You know, it can actually show you some really interesting things. I'm going to do something else to show you. I want you to look at it in this view. I'm going to turn it inside out. I'm going to do a negative. Okay, so here's a negative view of the same scene. This gives you, and when I was getting my degree in astronomy, we used negatives like this all the time, inverted imagery, because you actually see more detail. You can see some of the subtleties in this disk that you can't see at all if you are looking at it like this. Okay, like this. Sorry. Okay, subtlety sometimes is elusive, and sometimes there's stuff outside the galaxy that you just don't see. You know? 17 with no rejections. This is all good. So this is going to be all green. That's good. Oh, it's gorgeous. All these stars are here in our galaxy, and that galaxy is millions of light years away. How many millions? Well, glad you asked. Okay, this galaxy here, it has a, let's see if the distance is given. Oh, it doesn't give me a distance. I'd have to look it up, I guess. I get the parallax, but I'm not gonna. I'm not gonna take the parallax angle. Yeah, that's the wrong one anyway. It says parallactic angle. Yeah, okay, that's different. Okay, so this guy here, is there distance given for him? Because it'll be the same. Yeah, okay. This one here is 35.8, 36 million light years. This one's going to be the same, just about. This one will be about 36 million light years as well. So, but there it is, 36 million light years. I mean, the time it took for that light to get here that we're seeing right this second, okay, took 36 million years to get here. And now that we've seen it, it's gone, right? Those photons came, and went. Now they're on the sensor. If no one else was taking a picture of this tonight, we're the only ones on the planet that captured this galaxy right here, right now. It's pretty cool. Beautiful. What about the other one? Okay, let's see if our focus is done. Yes, we got a focus run is complete, and we're good. So now I have this guy right dead center, and that's Thor's helmet. So we're going to do a 25-second shot of that. And we'll go into our stack mode from this. And we're going to see the last image in here of the triplet. And when the Thor's helmet image comes in, it'll overwrite this one. We've saved this one already. Alright, so I'll clear it anyway. Alright, so we're going to see Thor's helmet. Another, and this is in our galaxy, another incredible region in space where an object is actually literally throwing off its outer layers. And this particular object is that star right in here that you see. And I'll try to make this as viewable as I can. Okay. That right there, that star, actually this star is what's called a Wolf-Rayet star. Wolf-Rayet stars are extremely high temperature, 50,000 Kelvin up to 200,000 Kelvin, and they're so powerful in their stellar winds that push the radiation out. And the stellar winds are composed of protons and electrons, and of course light radiation. And so when you look at this happening, you're seeing an object, for instance, that is actually pushing away the outer layers of the star and revealing and leaving only the core behind. And that's what you're seeing there, the core of the star right there. Okay? And that core of the star, and yes, I will zoom in as we get closer. Okay? That core of the star that you see right there, it's thousands of light years away. And it's still, in fact, I'll tell you exactly how far away Thor's helmet is. The distance, make a liar out of me. You don't have it. Yeah, I guess it doesn't have the distance. I could look it up, but the star, it's thousands of light years away. Kathy Pernasek, happy birthday! Happy birthday to you. Happy birthday to you. Happy birthday, dear Kathy. Happy birthday to you. I won't ask your age because you'll just rage. I won't ask your age, but happy birthday to you. This image is looking pretty nice, actually. Again, wide field scope. Let's go check it out if we can while this is cooking. Let's go look in the other scope. And here we are. Okay, so here is this galaxy. Look at this detail in here. Wow. Let's zoom in. We've got a number. Oh, look at this, guys. Look at that subtle dark cloud in there. There's a dark lane of dust right there. Look at that. Oh, unbelievable. Wow. This telescope, it does nothing but impress me every time we use it. It's absolutely incredible. Jeez. Again, I wish we could just use the color, but the color is not, it's not right. And I think part of the reason is because the moonlight is so bright. We're getting moonlight spilling into the telescope as well, because it's the right exact spot in the sky where the moonlight can spill in, and it makes the sensor get all messed up. What do you think of this, huh? Isn't that gorgeous? Wow, 32 frames. I'm going to save that one. That's measure 65. And we'll save exactly a scene. Look at the detail. Oh, man, there's such detail in here. Let me see if I can add a bilateral filter. The bilateral filter kind of does something. Let's see if I can. Let me see, lumen tolerance. Let's try that. I mean, the bilateral filter does tend to lessen some of the detail. But look at these lines. Look at these beautiful lines of material coming around. Oh my gosh. Really, really faint, detailed stuff. Dean Bostador, how are you? Nice to see you. Oh, Izabela says she's losing my audio. I don't know why. Maybe I'm talking too low. I can see what's happening though. You're right. I see something going on over there. Why is it doing that? What's going on there? I don't know. I don't know what it's doing. Okay. Huh. All right. Let me see if that's something to do with this. Okay, well, I'm maxed out, so I'll just talk louder. And I will see if I know that audio is low. I can't do anything about that apparently because I'm not sure. Let me see if this helps me. That's as high as it'll go. That's as high as it'll go. That's high. That's high. Yep, that's all up there. I can't do anything about this apparently. I don't know why. My oh my. Okay, well, I guess if I just keep the microphone more in front of me, that might. The mic is on whisper. Kate says, the mic is on whisper mode. You know. Yeah, it's like Airwolf used to be. All right. And it's okay. Thanks, Dean. No, you didn't lose more hearing, Dean. I have hearing degradation in my left ear, that's for sure. But I will keep my voice up. I probably, yeah, thank you, Kate, for saying it's good now. I'm talking louder, and I'm also aiming more into the mic, which I think makes sense. So I was just so excited by this galaxy that I forgot I was talking to all of you. Wow. Let's see how Thor's helmet's coming along. Oh, look at that. Oh, that's nice. That's really looking nice. Let's see if we can add a little touch of brightness to this. Yeah, they're seeing some extra detail in there. Let's try and see if we can separate the detail from the darkness of space. Ooh, look at that. We're seeing dark lanes over here. This is cool. Let's see if we color correct a little bit here. Amazing. Look at that, guys. That's beautiful. We have not seen Thor's helmet with this much detail out here like this. This is really, really nice. Really nice. Wow. Well, I figure you got two eyes. If you have two eyes, then you should be able to see two objects, right? Sure. So you got this one, the galaxy. Oh, that's beautiful. And then you got this one. Holy jeez, that's just amazing. Wow. Kathy, was my singing okay? I hope it wasn't that bad. But hey, Kathy, I hope you have a great birthday. You're wonderful. Thank you so much. And it's a privilege having you as a SkyTour family member. You know, Blues Traveler says Thor's hammer spans 30 light years across. Yep. Thor's helmet. Yeah. You're welcome, Kathy. You've been faithful and you've offered many great commentaries over the many years you've been with us. Oh, look at this. That's, I mean, I don't know when to stop. This is just beautiful. Okay, back to the other galaxy. Oh, look at that. Wow, that's gorgeous too. I'm just like so high on this. This is beautiful. Absolutely beautiful. Okay, that changes a few things. Now, if I bring up our values here, you see that's the wrong colors. If I color correct, it goes the wrong way. Thanks, Moon. It's the Moon that did that. Okay. But we come down and we're allowed to see all that detail. Very nice. Wow, unbelievable. Oh, that's something. All right, let me just raise that up a little bit. There we go. That's something else. Let's move this down now just to try and remove a little more of the noise. Wow. Okay, now that's something else. And then we can move this back off the peak a little bit. Yeah, look at that. Wow. Ay, ay, ay. This is really... I've never seen such beautiful galaxy. This is beautiful. Wow. Yeah, we've saved it. I'm going to save it at 50 too. It'll be 50 images we've saved. Okay, here we go. 50 images, measure 65. And now we're going to do save exactly as seen. Measure 65. Wow. That's something. Okay, now we're going to come out of this. All right. And we're going to go back to our low light mode. Okay, and once in low light mode here, not quite low light mode yet. I gotta get into low light mode. All right, here we go. Oops, sorry. Just a minute. Okay, we're good there. All right. Hang on. It's just I have an internet slowdown out there right now. I'm sharing the mountain with 9 other professional astronomers, so the internet is probably not behaving as it should. There's a lag, a long lag right now. That'll be fixed in a second. Meanwhile, let's go look at this guy. Ah, Thor's helmet. Look at that. Look at those beautiful red stars in there as well. That's incredible. Look at that. I'm trying to get us back so we can actually see that with the other telescope. Because in this telescope, this is how big it is. Look. That's how big it is in the field. Okay. So in the other telescope, let's see if we've got our operations back here. All right, let me do something here. I'm going to bring it back up. Let's see if we got, okay, we're in. All right. Yeah, okay, that's what I thought. All right, so we're gonna go back here. And do this. All right, so now we're back here, and I'm going to get us back to our 1 second shot here. There we go, and I'll maximize us there, and I'm going to reduce the size. Now we'll go back to here and zoom out of this, and I want to take us to Thor's helmet before it gets too low. Actually, it won't. It won't get too low. Thor's helmet's pretty high right now. We're good. All right, so let's go there. Let's go to Thor's helmet. And the telescope is gonna, you'll see the telescope moving. It's actually gonna swing around and go the other way. And you'll watch the SkyTour live stream indicator come over here and start to zoom in on this. As I zoom out of this, you'll see it moving across the sky. Here it comes. All right. And let's see how far off we are. We're at 40%. I'm going to zoom out a little more. Oh, actually, that was actually pretty good. Let's identify where we are. Okay, so what we'll do now is tell it to plate solve and resync. So what that'll do is it'll figure out where it is again, and then we'll take us to Thor's helmet and put it right in the middle of the view. And there it is. Very nice. Okay. And you can see it. It's big in this view. So we're going to do actually I'm going to come in here first. There's a lot of stars in here, so I think we'll be able to, I think we'll be good. Let me just drop out of this and Grab an exposure again. Okay, and then let's pick stars, one or more. Okay, we got 2 stars here, and we're going to guide on those. Excellent. So now what we'll do is we will do a 35-second exposure here. Okay. And we're going to come out of low light mode and go into a stack mode. Hope you guys are having a good time tonight. I'm really, really pleased with how the telescope is performing, even with the moon. How about that? I'll see if we can do a color version of this one. Depends where the moonlight is relative to the telescope. Huh. Uh-oh. Maybe not. Okay, yeah, that'll work. So Thor's helmet is pretty big. Now, it's also at an odd angle because of the fact that we don't have our field rotator yet, but we are getting it. And the field rotator costs around $400. And so donations tonight are definitely helping us. We're going to grab that field rotator so we can rotate this view to be identical to the other telescope's view. So no matter which way it's facing, we'll be able to rotate it properly. And that's pretty cool. Okay, so look at that. That's beautiful. Wow. Let me actually pull the color down a little bit. A little bit more. I just want to drop that a bit. Yeah, that's too muted. So right about there is good. Nice. Wow, that's cool. Our curves are getting better now. This is good. Let's see if this is... Okay, lost its lock on the star. We'll fix that. So we go back in here. Well, it claimed it lost its lock, but it didn't, did it? Okay. So, as you can see, this is the size of the field here. Okay. And with the other telescope, that's the size of the field. Look at that, huh? Right? So we're actually that much closer to it now. And we can see this star, which is the star that created this, the star that is responsible for it. Okay, that's pretty amazing that this size is now here. We can see all these other details in here that we just haven't seen before. Holy cow. And it's gonna just keep coming. Let me just move this up, darken up a little bit more. Let's do another correction. Look at that. And what's interesting is when we go back to the other telescope for a minute, okay, in this field of view, okay, we, in the other telescope, our field of view is something along the lines of this. Okay, now you notice this reddish brown bar here, okay, and that star. If we go to the other view, okay, you'll see that we're rotated a little bit, as I mentioned. Here's the reddish brown bar, and here's that star. So this should be up and this should be down. And so if we had the rotator, we'd rotate that properly so you could see both identical and see one and then the other, and they'll be perfectly aligned with each other. Looking so forward to that. Notice our red curve is behaving a lot better, even though it's unduly affected by the moon. You'll see it's acting a lot better because we were able to steer a little bit away from the moon. That's incredible. So you see this beautiful detail here. This is something else. So that's only 7 shots so far that we've done at 35 seconds. Unbelievable. And Isabel's asking a question. Donald Kunzer, by the way, happy birthday to you too. Yeah. Donald also asked, could the camera be confused by stars so close to each other? No, not those. What can be confused is the guiding. Okay, the guiding system here, you don't want the stars to be like merged, you know. Hey Elizabeth, thank you. Thank you so much. It's nice to have you here with us. Yeah. So the question then that was asked by Izabela is, do giant stars form by the same principle as the smaller stars? How do they escape that limit to gather so much more mass before becoming stars? Well, it comes down to this, Izabela. When you look at the way a star forms, the issues that we have with star formation are actually quite simple. The more mass you have, the bigger the star you have. And all stars start off fusing hydrogen into helium. And that's what happens. Okay? That's what we see. That's what we have happening with these stars. And so when we look at them, you know, we'll notice that the stars are more massive, but when they're more massive, they tend to be hotter as well. All right? But there is another. Elizabeth says, "You're the best. Show us the alien homes." Well, I am. Okay, except this one, Elizabeth. This is not one of the alien homes. This area right here is so hot and so ionized from this star, which is blown off its outer layers here, that you just. Yeah, there's no life possible in here. The ultraviolet energy in here makes everything in this region sterile. Okay, but don't forget, that's only temporary. Over time, stars like this will go supernova. All right, and when they do, this nebula will be joined by a supernova remnant, just like when we see the Crab Nebula, the Veil Nebula, the Jellyfish Nebula. Okay, Barnard's Loop. All these different locations are areas where there were previous supernovae, but you just see the nebula left. You don't see the hot star anymore because it's gone. It's been blown to pieces. Okay, so it's pretty cool. All right, so so here's our close-up that we have of this. Now you notice in our close-up, it's kind of fuzzy. When you do a wide field system, the views are better from far away because that's how they work. Okay, if we ride up the curve a little bit more, we'll darken it up, get a little more detail. Okay, and now you'll see this beautiful nebula with all these extents. We come back to our other view though, and to see that same nebula takes a little more time because, you know, we have 10 images taken so far with 3 rejections. As you see, they went up there. We have wind out in Benson, a little bit of wind, and once in a while it blows the telescope around enough so that one exposure gets dropped. But you see, we drop in the others. Okay, so we'll let this crank. Yeah, this is nice. Okay, Tricia Ferrer asked a question. Dean Bussador had a question, which I wonder about too. What is the really bright red star? Oh, I'm sorry, Dean and Tricia, I missed that question. Okay, in any field of stars, see, we got another bright red one here. Okay, these stars are very likely red giant stars. Those are stars that have evolved, you know, beyond the hydrogen fusion stage. And they're now fusing other elements outside their cores in these shells. And when that happens, the star pushes out its outer layers because the core contracts, everything gets hotter, it starts fusing new elements, renewed energy pushes outward and swells the outer star. and it becomes this giant red star. I'll give you an example. Betelgeuse is a bright red supergiant star. It's a red supergiant, right? Well, keep in mind that Betelgeuse is a red supergiant now, but it wasn't always a red supergiant. It was actually a hot blue O-type star. The O's are the stellar classes, okay, are O, B, A, F, G, K, M. O, B, a fine girl, kiss me, is what many people learned about to get the stellar classes. So O stars are the hottest and bluest. M stars are the coolest and the reddest. Now, it's all about temperature. The diameter of the star is a different characteristic of the stars. But when you have these hot blue stars, they can be giants, they can be smaller. But when you have these hot blue stars like this, their temperature is very, very, very hot. We're talking upwards of 35,000 Kelvin at the surface. Consider that our sun is about, 7,000 Kelvin at the surface, okay? And so when you look at the fact that the star's that hot, it burns through its hydrogen very quickly. And when it burns through its hydrogen quickly, it means that it starts to fuse other things. As the core contracts and it starts to push those outer layers out. And you get these stars here. You get these red giant stars. Okay. Now, you also see in here, you see that star right there? That little guy? That's a little red one. This is a little red one. There's a little tiny red one there. These are stars that are called red dwarfs, okay? And they could be supergiant stars that are far, far, far away, but because of the region of the galaxy, we would probably see them, but we'd see them being very reddened by the dust that they're passing through. As you can see, we're actually not capturing too many things right here. We are guiding, but I'm going to stop the guiding right now and reacquire the guiding right now. I'm just going to do that because I'm not convinced. There we go. That looks good. All right. Let's see if this guide's better. I will say this is looking beautiful already, though. Let's move this over. Yeah, we got that's wind. We got some desert winds out there. Benson is windy more than it's not sometimes. Look at that. All the way up to 15. That is definitely a gust of wind. Good thing we're capturing it though, huh? Yeah. Let's see what we're doing here. Yeah, it's having trouble staying at the right full width at maximum value. That's okay. We can wait out the wind a bit. Meanwhile, let's go look at our other telescope. Here we go. That's looking pretty. Oh yeah. Yeah, Thor's helmet is really exceptional. I'm going to do one thing. I'm going to take this and save this image as it looks right now. So that if you go up to SkyTourLive.org, when you go to the pictures at the database, you scroll down, you'll see Take Me to Cool Pictures. You'll be able to actually capture these, see these pictures, take them all down. These are all given to you free. All right, we're going to save this one right here. Save exactly as seen. Okay. Dean says the volume goes from low to high. That might be me, Dean, talking softly sometimes because I forget. Dave Mason. Hey, man. How you doing? Good to see you. Dave's a good friend of mine. He's a scientist and a good guy. We've worked on some things. We're going to work on more things together, I'm sure. I'm glad you could join us tonight, David. Good to have you here. This is Thor's helmet. It's this star right here is blown off the outer layers of this star here, well, of itself, and it's destined to be a massive supernova. So this whole nebula is going to get blown away, you know, in time. Yeah. That's incredible. Okay, let's see about our other locations. Let's see if we're getting anything back here. Yeah, it's coming down. We're waiting out the wind. Obviously you can see there's some wind here, and we're waiting to see. Oh, just almost got there. Our full width half maximum is coming down. You can see the wind's going up and then down, and I imagine the next one, if the trend is followed, the next one will be green. The next one will be a valid value. It'll take us to 11. That's my guess. So we'll find out. Come back to our histogram for the moment. Okay. And it did. See? Went to 11. Excellent. All right. Yes, do what Tricia says. Like and subscribe. Love to have you guys. Hey, you know, there's I don't make any money on this, okay? All the money that people donate, all the money you donate, it goes to enriching your experience here. It really does. I know that sounds like a line, but it's not. It isn't. It actually is not true at all. I am very much into making sure that your experience here is top notch, because my goal is to make people get excited about the universe and what's over our head that we just don't see, like this beautiful nebula, this beautiful, violent, cataclysmic nebula, and that's something that's really tough, you know, to instill in people, is to make them feel that the universe is a beautiful place. If they can't see it, you go out and you see gray skies, you see light lit up skies when you're in light pollution. Many of you here live in light pollution, and it's hard to see the forest through the trees. Okay, and in this particular case, we've got two telescopes we're showing you. This one and this one here. This is this is out in the Sonoran Desert. This telescope is 220 miles from this telescope. I've got them both open today. Both buildings are open. Okay, so there is the wide field view. Okay, 3 full moons across and 2 full moons tall. So 1.5 degrees by 1 degree. And then this one is just about the size of the full moon. It's a little over a half a degree across and just a little bit less tall. Yep, and goblins with this. Hi, Goblin. Blues Traveler says he lives in a nice dark area. That's cool. Gotta love dark skies. You know, I have to go to Colorado and teach in August, and I'm going to be in a probably the darkest sky in the United States. So you have to be prepared for that, because when you look at a sky that's as dark as where these telescopes are, or where I'll be in August, you're looking at a sky that literally will take your breath away. It will make you hyperventilate, I promise. It's very, very hard for people to understand how dark a dark sky really is. They're so used to some level of light pollution that if they go where they don't see any, I've seen people that are experienced at life go see a dark sky for the first time and they collapse in a ball and they start crying. They have no idea how dark the sky really can be, you know. And that's what we see, you know. Now our full width half maximum filter is now delivering good images again out here. That's 14 of them so far. I will save this though, just to keep it safe. All right, and then we'll save exactly as seen. That's Thor's helmet there. And we're going to save it with annotations so that the image you actually get will be this one that I'll show you right now. So you're going to get Thor's helmet like that. This is the full field. Okay, but that's not what you actually get. What you actually get is the saved image that I saved for you. And it won't have the annotations on it at all. Okay. Tricia Ferreira lives on Whidbey Island. Okay. Yeah, it's raining on Whidbey Island. Yeah, that part of the nation is actually a rainy spot. Yeah, this is the first stream we've had in a couple weeks, guys, because the sky has been uncharacteristically cloudy here. And where I am right now, we've had nothing but rain for the last week and a half. So it's actually tough for me because, you know. Sally Force says, this really is life-changing for me. Pittsburgh sucks. You know, yeah, that's true. There's a lot of areas that, and when we say sucks, we mean it's light pollution is bad there. Let's go to our other view. What do we got? Oh yeah, look at that. That's pretty. And it looks like if we, oh wow, it looks like we have 87 exposures in this view. All right, I'm gonna save that. Okay, and I'm going to save it exactly as seen as well. Very cool. And now we come back to our other view. Okay, we got 2 more greens. That's good. 17. We're going to go to 20 on this, then we'll stop. Very nice. And this will be our last object for tonight. When the moon, see, I would have been streaming if the moon was a younger moon, but it was totally cloudy out there. Both locations. You know, this location in Benson and this location in the Sonoran, west of Phoenix by like 75 miles. They were both clouded out for the last couple weeks. So it was really tough. Last week and a half, I guess. So this guy in the Benson Plateau, we're at 3,600 feet, and it was clear there. You know, tonight, actually, if I look in Arizona right now, there isn't a single cloud in Arizona anywhere. You know, Dave Mason says it's also raining in Newcastle, Washington. It's difficult to conduct astronomy in this state. Yeah, that's true. That's true. Hello, Kathy Messick. Nice to see you. So, you guys, it's okay if you can't see the stars where you are. Just join us here. I feel like that's Gilligan's Island. Join us here each week, my friends. But we show you the cool things that you just don't get to see. And I really like doing that for you guys. Now, one of the things that we're going to add to this building, and I hope we can get this sooner than later, is we're adding a spectroscope, a spectrograph. And what's going to happen is, when you look at this, I'm going to tell you what's going on here. you'll see this red glow, and you'll see this greenish blue glow. Okay, this greenish blue glow is ionized oxygen, doubly ionized. 2 electrons bounce up to higher states and leave the atom for a period of time. Okay, and when they come back into the atom, they give off this blue light. They give up energy, and that's this teal blue light. Hydrogen only has 1 electron, but when it leaves the atom and comes back in, it gives off predominantly 1 color, and that's red. So what's happening here is these are emissions, okay? And they produce a different look in the spectrum than what we'd see if we looked at the star. The star would have, thank you, Tricia, that's very sweet. The star that's in the middle here will have a spectrum that has something called absorption lines in it. There's an outer atmosphere, not much though, in this particular star, and it's going to have a much hotter core underneath it, and that much hotter core is going to go through that relatively cooler gas that might only be 50,000 Kelvin compared to several million Kelvin, okay, in the middle. A lot higher than that, tens of millions of Kelvin in the middle. And so that's going to create a dark band in the spectrum, and we're going to be able to see those bands. Then if you look at the emission, you're going to see a bright peak, and that bright peak is going to be at a specific spot in the spectrum, and that specific spot is a well-known position because all the different elements in the periodic table will emit at one particular location and no other. Okay, well, one element can have 4 or 5 different lines, but they're always at the same place in the spectrum together. All right, so that's how we figured out distances, because when some things are moving further away, the lines are shifted into the red. When something's moving toward us, the lines are shifted into the blue. And we do what's called a radial velocity measurement, okay, of a star that's moving quickly toward us or away from us, or a nebula. And so we can actually gain a lot of information by looking at that light that's broken up and becomes a spectrum that we see. It's amazing what can happen. And we're going to get a system, we want to get a system that's going to allow us to do everything we're doing now, like this in this telescope. And then in a third telescope, which we'll have, you'll be able to actually see what is this thing made of. We'll be able to say, this is doubly ionized oxygen, this is hydrogen. Oh, and guess what? It's actually neon too. You know, we'll see all these different elements in the spectrum. And those elements, remember, stars are element factories. They build the periodic table. So we'll be able to see all that. And we're going to see it dynamically. We're going to be able to see it and say, wow, look at this, a spectrum we just took. And now you can see every single element that is being made by this star and by this nebula. Isn't that something? You know, and we're still going to do the pretty shots too. You're still going to see all these pretty shots as well. You know, so that's pretty cool. Now let's go back here. Still guiding, still going. Doom, doom, doom. Okay, I love it. Yeah, so here we are, and I do want to go to 20, so I'm waiting for my 20th shot here. I got 18. You know? Oh. Dean Bustador says, there's 19, all right. Dean Bustador says, now that I'm retired, I can observe and hang out here much more. Hey, man, we love having you. Trust me, we love having you. And Michael Hedrick says, I tell everybody at work about Mark, my astronomy friend. Yeah, okay. Oh, that's cool, Michael. Thank you. Well, look, if you guys are interested in other things that I do, you can also check out History Channel, because I'm on the show called The Proof Is Out There. I'm their photo and video analyst for a lot of the videos they produce. I do believe in extraterrestrial life, and I do think it's here. I mentioned earlier in the stream about the methodology by which that might happen. Look, we got 20. And that methodology could be interdimensional travel. And that's not, to me, that's not a bad thought process. It's been around for a long time, that the possibility. However, it turns out that it's been kind of relegated to like a second fiddle theory until recently. Okay, CERN at the Large Hadron Collider overseas, where they have the big particle accelerator at 20 some odd miles around. Okay, that big ring is making particles that, by accelerating protons at high speed, near the speed of light, and then letting them collide, they actually create other particles. And among the particles that they've been looking for and found are particles called Kaluza-Klein particles. Kaluza, K-A-L-U-Z-A, and Klein, K-L-E-I-N. Kaluza-Klein particles are particles that are very interesting. And they spent millions upon millions upon millions of dollars building a detector to, in part, detect them. Okay? And the Kaluza-Klein particles are the secret to getting out of the 4 dimensions, getting into the 5th, and being able to pop back in again. How about that? So we're on the verge. Now, what would you need to generate that for a small ship? I mean, we have all this energy going into a giant particle accelerator to make a few of these Kaluza-Klein particles. What if we wanted to put them in a spaceship and make them in a spacecraft? What would we do? Well, the way to do it is to use a reactor that would allow us to generate these Kaluza-Klein particles and run a much smaller particle accelerator. Okay? And that much smaller particle accelerator would probably be controlled and run by a fusion reactor, which is what Lawrence Livermore is doing in California. Okay, they're working on that. So, you see, it's coming together. It's all coming together. Interstellar travel may be just around the corner, really in for true. Okay, and I did my entire lecture that I do. That's one of my more popular lectures around the country that I do, is that one, the interdimensional travel of the aliens. In fact, I'll be doing it at Contact. I'll be doing it at Pine Bush in June. I'll be doing another one actually on that in August. I'll be doing that out in Colorado, and people love it. I'll be doing it May 7th actually too, here at a winery. I'm hoping to become I don't drink wine, but I'm hoping that people enjoy astronomy while enjoying a night of wine and skywatch that we'll do. But this interdimensional travel thing is actually something that's actually going more mainstream now. As I mentioned, Harvard University is on board with this through Avi Loeb to some degree. And it's really something that is coming full circle. It's gone from a potential theory that was considered silly to now being something that's actually considered possible. And that's where I leave you for tonight. Okay, this is our last image for tonight. This is 24 we've taken here of Thor's helmet, an object that is so far out there, several thousand light years away. Okay, and we'll save it exactly as seen. Okay, all right. So that said, I think that I will leave you with that tonight. I'm gonna just go back to my low light mode here. Okay, and then we'll just do that. Okay, so this is this observatory, and then over here 200 miles away we have this observatory, and we're going to save this one last time. It's 113 exposures. We've just been letting it go, and when the moon's out it's hard, so you got to do more just to get good data. Look at that. That looks nice. So we'll save it, and we'll save it exactly as seen. Now I save as what's called a FITS format and a PNG. The ping format, that's this one. I'll show you. That's what you get if you go to our server at skytourlive.org. You can download this image. It doesn't cost you anything. They're all free. Okay. If you want to join our Patreon, or donate to us, you can go to SkyTourLive.org and click the donate button. Okay. Love having you. We love being able to do this. Tonight and on the last stream, I think we got enough donations to actually consider getting our field rotator now. I'm very happy about that. We're going to save this exactly as seen. We'll save it in exactly as seen, because this is now the right color rendering. So, love to have you. This is great. But I hope you guys enjoyed tonight. All these images are all available up at, like I said, SkyTourLive.org, and scroll down and you will find the Take Me to Cool Pictures entry in on our portal, our website portal, SkyTourLive.org, and you can go grab all the pictures you like. And we really are trying to come out with a application. Izabela wrote, Izabela in the chat. You know Izabela's our superstar, right? She's one of our superstars. And she wrote an application that shows all the observations and all the images we've done since 2021. And the database is huge. And you can see every time we did Thor's helmet, for instance. You can see every time we did the Orion Nebula. Every time we did this and that and the other. Incredible. Incredible. Okay? But you guys have a good night. And I look forward to coming back, doing this all again with you. So, thanks for coming out, and have a really wonderful night. So, good night, everybody, okay? Don't forget, Patreon, SkyTourLive.org. Got an email? Want to email me? It's ContactSkyTour@gmail.com. All right? So, we'll see you later. You guys have a good night. Bye-bye, everybody.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.